Hello, my name is Nitaj and I am going to be talking about this week's experiment, which included moving average filter, derivative filter, and 3-point central difference derivative filter. First of all, let's look at the moving average filter. In the first line, I have written the input as x of 300 and given the data type as float because it's having values after the decimal place. After that, I have written the output as y of 80. Here I have given the size as only 80 because of the size constraint of the Arduino board. After that, I have written void setup serial.begin 9600. This is actually initializing the Arduino, and this number 9600 is actually the data transmission rate. After that, I have written void loop. This part actually gets executed continuously in the Arduino. And in this for loop, I have written y of I is equal to x of I plus x of I minus 1, etc. x of I minus 7 divided by 8. This is actually the averaging part. I have taken 8 numbers and took a sum of it and divided by 8, which is actually taking its average, and given that value to the y of I. And next part is the actually printing. This is printing the input, this is printing the output, and this 300 is actually separating these two. Otherwise, we'll get input and output mixed up with each other. Let me show you the graph. Here, as you can see, all the high frequency components have been removed and the graph has become much smoother. And we can see that this is actually the baseline of this signal. So if we were to increase the number of numbers that we are taking average, we can get more and more smoother curve as output. So we can say that this moving average filter is acting like a low pass filter, and this is actually low pass filter of worst kind. Next comes the derivative filter. This is derivative filter of first order. Everything is the same except for this part. Y of I is equal to x of I minus x of I minus 1. So this is derivative filter of first order. If we were to see the graph, we can see that the baseline have been removed from the graph and it has given emphasis to the high frequency components. So this is acting like a high pass filter. So this derivative filter emphasizes the high slope area in the graph. Now next comes the derivative 3-point derivative filter. Here everything is the same except for this part. Here we have written I minus 2. If we were to compile it and run it, we can see the plot. See, you can see that this is the input and this is the output. Here the baseline have been removed because it's having low frequency, and all the higher frequency have been emphasized. So it's actually doing a better job of emphasizing the higher frequency than the derivative filter of first order. So both of these filters are acting like a high pass filter, and the moving average filter is acting like a low pass filter. So that's all for the experiment that we did this week. Thank you.